able to. Perfect. 4.4. Let's go ahead and get started. 4.4 are on applications of linear systems. At the time we get to 4.4, there isn't anything new that you do in 4.4. It's kind of a summary between 4.1, 4.2, and 4.3. What's going to happen on 4.4, when I look at what we have to do, it's literally word problems. There's not a lot. There's only, and I'm going to, well, no, there's 12 on this worksheet. And focus. And I'm going to be cutting off a couple of the problems. So, there is nothing new. The only thing is you have to end up writing equations for these word problems. So that's what I'm going to do. I'm going to give you a couple of things to write down that are going to guide you as you do your word problems. The first thing I want you to write down for 4.4 notes is, there are always two equations. There are always two equations. When you are doing the problems on 4.4, just remember, I need to have two equations. The second thing I want you to write down is use variables that make sense. I don't think that should be makes. I think it should be make, that makes sense. Use variables that make sense. Here's what I mean by that. Don't always use X and Y. If you have a problem and let's say that we're looking at number 6 and we have to do something with children's tickets and adult tickets, don't use X and Y. If you have adult tickets and children's tickets, you should use something for adults that's nice and easy. What letter should you use for adult tickets? A. Exactly. And what should you use for children's tickets? Do that every time. Don't just use X and Y. That's why I say use variables that make sense. Sometimes it's not going to be as easy. Let me give you another hint on that. If you have to do hot dogs and hamburgers, don't use H and H. That way doesn't make sense. So you might have to call a hot dog something different. You might just call it a dog instead of a hot dog. Some people do call them that, by the way. You might want to use a D for the hot dogs and an H for the hamburgers, just saying. Basically, be able to tell the two variables apart from each other. Sometimes you're going to need to do a smaller number and a larger number. Don't use X and Y. If I want to know what's the smaller number, what's the larger number, use S for smaller and L for larger. That will help you. Lastly, the last thing I want you to write down is try to make equations that measure the same units. Try to make equations that measure the same units. For example, if you have a price plus another price, it should equal a total price. That's the same kind of units. If you have the number of these type of people, plus these type of number of people, then it should equal a total number of people. Total number of people. That's what I mean by the same units. A lot of these problems will end up having you make equations, and you want to keep the units separate. I'm going to give you an example. We're going to do number 6 together, okay? I'm not going to have you write down number 6, but I want to show it to you. It looks like this. A community-sponsored charity square dance. If you don't know what that is, it's what country music folk do out in the East Coast, okay? Where admission was $3 for adults and $1.50 for children. If 168 people attended the dance and the money was raised was $432, how many adults and how many children attended the dance? So what you have to do is come up with 2 equations. That's what part A asks you to do. What are the 2 systems of equations? So keep in mind there's always 2 equations. If I see $3 for adults and $1.50 for children, then I know this is a price and this is a price, and so I need it to equal a total price. But what they do is they throw in this 168, which is not a price. So you need to not confuse it. You don't use this with the price and the price. You use the 3, the 150, and the total price of $432, which was what was raised. Your first equation should be something like this. $3 for the adult. $3 for the adults. Plus $1.50 per children, or every single child. Yeah, that's better. $3 per adult plus $1.50 per child will equal a total price of $432. Dollars. They are the same units. That's your first equation. Your first equation deals with something that has the same units. Now going back to the problem. So we use this, the price, and this price. What we didn't use was this 168. The 168 people attended the dance. This was kind of hidden. If there's 168 people, that's made up of who? The adults and children are the ones who attended it. So you should have a separate equation that deals with how many adults, bless you, and plus how many children equals a total how many. Let's look at the second equation. This is what I have for my second equation, which is the number of adults plus the number of children equal a total number of 168. Because I have it this way, you get a choice. You can use the graphing method. I don't recommend it because these numbers are really big. You could use the substitution method. I don't really have a variable by itself. Or you can use the elimination method, which probably makes the most sense here. If I add 3A and A, or 1.5C and C, does it eliminate? So which one do you want to get rid of? Do you want to get rid of the adults, or do you want to get rid of the children? That kind of sounds funny, doesn't it? Let's get rid of the children. All right, let's go. like we're okay. That's bad. Sorry. In case anybody's listening at home, I apologize. Okay, let's multiply by -3, and we'll get rid of the adults this time. That makes sense to me. If I multiply the bottom one by -3, then I get -3 times A, -3 times C, -3 times 168. And then I know that the number of adults will eventually cancel out. So here's what I'm going to get. Sorry, Savannah. What? So I leave the top equation by itself, and the bottom equation is -3A minus 3C, and I use a calculator for -3 times 168. It comes out to -504. And those numbers are really big, so I do recommend using a calculator. Go ahead, Chase.
What does that say at the end of price?
That the end of price plus price equals total price. Mm-hmm. I put these together. 3a minus 3a goes away. A 1.5c minus 3c. I just punched that into my calculator. I did 1.5 minus 3. And I switch it to a decimal. It's negative 1.5, in case you need that. And then I plug that in my calculator, and I got negative 72. And then I could take that negative 72 and divide it by negative 1.5, and I can figure out that the number of children that attended, it does come out nice and even. It's kind of nice. Negative 72 divided by negative 1.5 is 48. And this is a good point to say it doesn't make sense if you got 3.5 or 2.5 kids or 2.5 adults, something like that. These should be nice whole numbers because that makes sense. We don't have half of a child, right? Like that's how it goes. So, children's 48. You can plug that back in, probably to this equation, makes it the easiest equation. When you do, you get adults plus 48 equals 168. You can find out the number, when you plug in that children, you can find out the number of adults is 120. Let's stop your notes right there.